Hi, it's me, Jazzy. I'm back with another tech-related video, and today I've got something rather unique to show you. It's this. It's a homemade current dumping hi-fi amplifier. Not made by me. This was given to me by a friend, and it was rather dusty when I got it. I had to give it a bit of a dust off, I have to say. Now, my friend acquired this amplifier some years ago. Now, the story goes that it was built by an apprentice who wanted some form of hi-fi but had very little money but good electronics knowledge. So they built this as a way of getting some hi-fi. Now, this was an early concept and didn't deliver a great deal of power due to the limited parts that they had, mainly the small power transformer, which is why there was at the time no need for heat sinks on the voltage regulators or the output transistors. Now it's a fully integrated stereo amplifier with volume, treble and bass controls. It's got a line input and a vinyl record deck input, very handy. And it's got a separate RIAA phono cartridge preamp board. It's a bit unusual that it's built on a bit of plywood, but it's very neatly constructed, all built on Vero copper strip board. The wiring's all neatly laid out. It's really neatly done, and it's secured down with these U-shaped metal staples. I guess that's all they could get at the time. Now, the design of the preamp board and tone control circuit is all fairly standard, but the power amplifier stage is quite unusual. It's what is known as a current dumping design. Now, this amplifier is around 40 years old and it's been in storage for a long time. So I'm sure it's going to need a bit of love. So I'm going to get it on the bench in a minute and see what it needs. Now, after we've taken a look at this amp, I'll show you a drawing with the full schematic for the Mark II version, which is what the apprentice that built this drew. And the Mark II is based on bridge amplifiers delivering up to 70 watts as a stereo pair. So make sure you watch until the end and we'll have a proper look at that. So here's the schematic for the power amplifier part of the design. So looking at the schematic, all the voltage gain right out to the connection to the speakers is provided by an op-amp IC, but the op-amp can't provide enough power to drive a low impedance speaker. So a set of 4 transistors are used to boost the current provided by the op-amp in order to deliver the power required to drive the speakers. There are 2 transistors for the positive cycle and 2 for the negative. Each pair of transistors is configured as a Darlington pair in order to give high current gain. The current gain of a Darlington pair will be the current gain, or HFE, of the first transistor multiplied by the current gain of the output transistor. The Darlington transistors are biased by the voltage drop across the 82 ohm resistors in the supply pins of the op-amp. The whole thing is controlled by a feedback resistor on the output back to the negative input of the op-amp. The entire amplifier consists of just the op-amp, 4 transistors, 4 resistors, and some capacitors for stability. It's a surprisingly simple yet elegant design that works extremely well. Okay, enough about the design. Let's get this on the bench. I want to see what work this needs to get it back in working condition. So the first thing I did when I got it on the bench was check the condition of all the capacitors. Amazingly, the ones on the power supply check out pretty good, but I'm not happy with any of the ones on the phono stage, so I'm just going to yoink those out. There's 5 electrolytics on there. Going to replace those with some nice new ones. Give this amp the best possible helping hand. And it doesn't take too long with the desoldering tool to whip those old ones out and put some nice shiny new ones in. Then I'm going to power up gently using the Variac to give the power supply caps their best chance in life. Unfortunately, on powering up the amp for the first time, I checked the voltages and something is not quite right. Here begins the saga of the tantalums. So looking at the voltages, right, so we've got plus 25 there, plus 15 there, Yeah, nothing there. We should be looking for minus 15 on this one. We got minus 0.3, so something's not quite right. And something's getting hot. Ooh, yeah, the voltage regulator's getting toasty. 40 degrees. Sounds alright. 30, 30. Yeah, something's gone short. Wonder if it's that tantalum. Right, I think we'll power this off. Yoink this out. Let's get those tantalums out. Okay, so we're not getting any output. We know the voltages are not correct as to what they should be. And we know that something's getting very hot here. I am very suspicious of this tantalum. It does look slightly darker than the rest, but it could be just me. This tantalum here, this here, this is where the heat is. Something's gone short here. I've got plenty of tantalums in stock, so let's yoink these out. See what we got. Could be one of these pesky tantalums. Right, let's just remove this cable clip so I can get this board out. Oh, you can see the tracks. They've tinned the board to cope with the voltage. Very nicely done. So I'm going to remove these tantalums using the desoldering gun. Really handy bit of kit for jobs like this. That's one. Looks like it's 4.7 microfarad, 35 volt. Let's check it on the T7, see how bad it is. Yeah, that's really is no good. Short of 4.8 ohms. Wow. Good job it wasn't 0 ohms. Would have gone pop. So here's the replacement one. That's a bit more what we're expecting it to be. So I'm going to replace both these tantalums. If that's gone short, it's possible that's why the voltage regulator is getting hot, and that's why I'm not getting my minus 15 volts. Right, let's get the other one out then. Well, we don't know for sure that this one's dud. That's the thing. But we're going to check it just to be super safety sure. 5004 nanofarads, otherwise known as 5 microfarads. That's okay, worth checking, but if we're replacing one, we might as well replace both. Now, let's get this back in. Well, it'll either work, or it won't, or it'll go bang. Either way, it'll do something. If I get minus 15 on here, then we're good to go. So I've checked the voltages again. This is still getting red hot, still no minus 15. It's possible when the tantalum went, it might have took the voltage regulator with it, or vice versa. Who knows? Either way, I've got plenty of these in stock. They're pretty cheap. Let's yoink this out and put a new one in. And the desoldering tool is on overtime for this one. Just makes the job a little bit easier. Right, there we go. So we've got a nice new one here. We're going to put in instead. Whip that one out and put that one back in. So let's solder that one in. Right. Now, will this solve our power supply problem? Okay, let's get this 7915 soldered in. As usual, I've sped up all the boring bits. I think that's toast. Okay, so I've got my probe hooked up to the earth there. Power up. Okay, so let's have a look. We've still got our 25 there. That's good. Plus 15, 0 volts. And, oh no. Minus 0.5, that's not what I was looking for. And on the regulator, minus 0.5. Something's still not right here. Right, so plan C is I'm going to take these off, and then I'm going to power it up with just this to see if the short is on this board or if there's a problem with this. We have now detached everything from this power supply, so we can now power this up and see if we can replicate the fault without the amplifier attached. Theory says that if this behaves and we get the voltage and it's not getting hot, then there's a problem with this. If this still gets hot, doesn't create the voltage, there's a problem on this board. Right, okay, so place bets now on what it's going to do. Plug it in again. So amplifier is not hooked up in any way, just the power supply board. Let's see, is it going to get hot? What have I got on that voltage regulator? Minus 0.8. And at the pin, minus 0.7. Right, the problem is on this board, not on the amplifier then. Right, so now we know the fault is on here, not here. That's a good thing. Okay, so the plot thickens. So with all the cables detached, we could still replicate the fault in the power supply. So that discounts any of this section, which is great. So we know there's not a short in here somewhere that's pulling down the power supply. So we know the fault's on this little board. There's not a lot going on this little board, to be honest. So there's not that much. This area is the area that's getting hot. This voltage regulator is getting super hot. You can't actually touch it when it's powered on. And there was a little ceramic capacitor here, and this is supposed to be 100 nanofarads. Now it's reading a little bit low. It's not like horrendous, but enough that I'm just going to replace it. You can see it's reading 81.2 nanofarads. There is a method in my madness here. This is its replacement, which is 92.4 nanofarads, which is going to be a lot better. Now, one thing I didn't suspect is the tantalum that I replaced here has actually gone short again. So this is the replacement tantalum that you just saw me put in before. This is now short to 1.64 ohms. So that's a goner. Now, whether that tantalum was faulty or whether the old voltage regulator, which is this one, was faulty and pulled the tantalum over with it, I'm not 100% sure yet, but all I can say is that tantalum is no good. That's reading below what it should have been. And I have yet another replacement tantalum from stock. That's going to go in along with that. Now, what I can say is, if I power this up now, without those components in, that will not get red hot. And more to the point, let's have a look at the voltages. So on this regulator, there's our minus 15. That's what we were missing. We should have had minus 15. And at this pole here, which is where our minus 15 wire goes to our minus 15 rail on the board, we've got minus 15. Look at that. Minus 15, 0 volts, plus 15, and plus 25. Great. And of course 0 on that one. That's it. Fantastic. Minus 15, 0, plus 15, plus 25. That's what we should have. Fantastic. Now what I need to do is to put this tantalum and this capacitor back in. Repeat that test. If I'm still getting the correct voltages here, then I can solder these back on and we can test the amplifier section. Okay, let's get these in. So we know these are going across this regulator here. Right, good old tantalum. Right, you behave this time. Goodness me. Problems we have with tantalums, eh? So for anyone at home that's counting, this is tantalum number 3 going in. Right. Shall we go again? What is this? Not third time lucky, is it? Okay. So, powered on. Okay. Voltage regulator. Still minus 0.2. Do you know, I'm really starting to doubt this batch of tantalums. This is the third one from the same source. I need to find one from a different source. So I'm going to harvest one from this dud bit of equipment I've got here. I'll check it before I put it in. It's also got a 7915 voltage regulator in here. Out comes yet another tantalum. Number 3. That's a goner. Oh my gosh. What's this one? Let's have a look. So what have we got on here? 26 picofarads. Oh my gosh. Okay. Wow. Not only shorted out, it's now open circuit. What is going on with these tantalums? I'm going to take the ceramic out, double check that that's okay. Now that's still all right. Not a problem with that. I didn't think there would be, but it's worth checking everything. And with that out of the way, still just getting minus 0.2. So yeah, I'm wondering if that tantalum's failed so hard that it's taken the voltage regulator down with it. So I'm going to use a harvested tantalum and voltage regulator now. I'm not going to use any more from that batch that I've got. There's clearly an issue there somewhere. So out comes the completely toasted 7915. Really is a game of persistence, this amp. Okay, out with the old 7915 and in with this one that I've harvested from a bit of gear that was in the parts bin. Right, let's get this one in. I've lost count of how many bits we've replaced. Who's counting? Right, let's try again. Plug it in, put the meter on. Let's do this one more time. Wait, minus 16. Minus 16. I'll take that. Let's put this back in, see what happens. Okay, so I'm still getting minus 16 with the ceramic capacitor in. So let's put my harvested tantalum in, solder that in, and let's go again with the meter. On the regulator, minus 16, that's fine. On the output, minus 16. 0 volts. Plus 15. Plus 25. We made it. It was just a series of faulty components. That's not getting hot, you see. Great, so I'm going to solder all the wires back on now, so we can go for one more check. So I think that's our 4th tantalum and our 3rd voltage regulator and the 2nd ceramic capacitor. So let's get that board screwed back on. Right, back to the other bench, hook it up to the scope. Okay, going to use the Marconi to put a signal out. Turn that on. Okay, so I've got my test leads hooked up. I've rigged up some jack plugs into the input so I can just put some croc clips on. Got the signal coming out the Marconi going to the input, and I've got the speaker outputs going to my scope. There we go. Nice clean waveform. Yeah, you can see that changing quite nicely as I turn the volume up and down. How much we can get out of it. Let's see if we can see where it's peaking. Right, so that's at its max pretty much before it distorts. So 5 volts per division, 5, 10, 15, 20, yeah, 25 volts peak to peak before it distorts. A little bit of a wider shot here. You can see some of my other projects on the bench. Yeah, you can see the volume's quite nice. It's not even too crackly actually, the pot on that. The tone control working nicely. Nice clean waveform coming out of it. So yeah, I'm pretty happy with that. It seems to be doing what it should be doing. So I reckon let's hook up some speakers to it. Let's make use of the phono stage in this and hook it up to a record deck. Why not? So as you know, I love a good lash up, and this is a great lash up. So we've got our amplifier here. I've got it hooked up to some 1970s Ekrel speakers with the lovely oval drivers and a Pioneer record deck because it was handy, and I've got it hooked up to the phono stage here. Right, all I need now is a record. Now, I can't play you much of this, unfortunately, but there we go. There you go, maybe 40 years old, and it needed a lot of love to coax it into life. But nothing's getting hot. Sounds all right. There's a win for me. Well, that was quite the journey, wasn't it? Oh my goodness me. That was what, 4 tantalums, 3 voltage regulators, and 2 ceramic capacitors to get this thing in working order. There was a whole bunch of components, including tantalums, that came with this. So it's possible that that batch was just either no good or hadn't been stored properly. I don't know. But the one that I harvested from a dud bit of test gear from my parts bin seemed to do the job nicely. And it's good to have the amp back up and running. It was great to actually get some tunes out of it. Right, so now that's finally up and running. Let's take a look at this schematic. Now, this came with the amp, and this was drawn up by the apprentice that built this amp some years ago. This later design was built into a high-powered ghetto blaster, apparently. I've never seen this thing. If I can ever get hold of it, I would love to, because I'm sure you'd love to see it. But I don't know if it's even still in existence. Be quite cool, though. So taking a look at this schematic, so the entire schematic here shows the volume control, bass and treble controls, plus a differential driver stage that feeds into a bridged version of the amplifier, providing up to 35 watts into 8 ohms. Not bad at all for some op amps and a handful of transistors. There's some measured specifications listed as well down on the right hand side of the drawing, so they've obviously done some measurements from this. Apparently this ghetto blaster device, based on the bridge amps shown here, is quite something. As this design uses standard components, you could in theory still build this design today, some 45 odd years later. So I hope you've enjoyed this video today, taking a look at what is a really unique piece of history, an amp made by an apprentice on a low budget some 45 odd years ago. How fantastic is that? Now, as always, massive thanks to everyone for watching, sharing, liking, commenting, and subscribing. It's always massively appreciated. I'll be back soon with some more videos on test gear repairs, audio repairs, and electronics kits. In the meantime, take care, and I'll see you on the next one.